Hello and welcome back. This video will continue looking at other sorts of equations other than just quadratic equations like we were doing in the last section. However, when we look at this, this looks a lot like a quadratic equation. We have 3 times x to the 2 over 3 power minus 11x to the first, or I should say 1 over 3 power minus 4. So this almost looks like a quadratic equation, except that we have this factor of 1/3 in the exponent. So what we can do is we can actually replace this variable with another one to make it look exactly like a quadratic equation. So to make this clear, notice that x to the 2/3 power is the same thing as x to the 1/3 power squared. And again, x to the 1/3 power, I can separate that out. And now I have 3 times something squared minus 11 times that something minus 4. So I can replace the I can replace x to the 1/3 power with u. Let me just erase that. And in doing so, I have 3 times u squared minus 11 times u minus 4 is equal to 0. This is a quadratic equation, and we can solve this. This is in fact factorable. We have a 3u squared, so it'll be 3u plus or minus something times u plus or minus something. What we put back here and here, we'll have to multiply together to get -4. And as it turns out, if we do this in this order, everything will work out. We'll have 3u squared, we'll have 1 times -4 is -4, 3 times -4 is -12, plus 1 is -11. And we have all this is equal to 0. So again, we use our zero product principle to say that one of these two things is going to have to be 0, which means that I can solve for u. So here I'll just subtract 1 from both sides, and then I'll divide both sides by 3 to get u's -1/3, or if I add 4 to both sides, I'll get u is equal to 4. So it's either this or this. Now, the thing is, our original equation was not in terms of u, it's in terms of x. So I don't care about u, I care about x. So what I'll do is I'll sort of unreplace the u with an x. I'll substitute the x back in to get x to the 1/3 is going to be -1/3, or x to the 1/3 is going to be equal to 4. So ultimately, how do I solve these? Well, I need to get an x by itself. So we'll take both of these and raise that to the 3rd power. And x to the 1/3 to the 3rd power, well, 1/3 and 3 cancel out to just give me x. And this side, I can just take both the top and the bottom, raised to the 3rd power. -1 times itself 3 times is -1. 3 times itself 3 times is 27. And I can do the same thing over here. I can raise that to the 3rd power, raise this to the 3rd power. X to the 1/3 to the 3rd power is going to be x. Again, 1/3 and 3 cancel out. 4 to the 3rd power, 4 times 4 times 4 is 64. And again, at the end of each one of these, I should plug these back in and make sure they work. I need to check my solutions. In this case, both of these work. So using this substitution to make something look like a quadratic equation is very handy, and sometimes it's a little bit more explicit than others. For instance, in this example, we can see that we have something squared plus that same something minus 6 is 0. This is just a quadratic equation staring us in the face. If I let u be x squared minus 4, I can replace the x squared minus 4 in here with a u. I can replace this x squared minus 4 with u. And I have another quadratic equation. So this is going to be a common theme where you can make an equation look simpler by replacing something that shows up with another variable. So here again, this is factorable. We'll have a u and a u. I need two numbers that multiply together to get 6, but add together to get plus 1. So if I take plus 3 and minus 2, 3 times negative 2 is negative 6, 3 plus 2 is 1, and all this is equal to 0. So again, we solve these. At least one of these two things must be 0. So u is either equal to negative 3 or u is equal to 2. But again, I don't care about u, I care about x. So I need to replace u with x squared minus 4. And then I'll replace u with x squared minus 4. And we can solve for x. So again, here I will add 4 to both sides. So if I add 4 to negative 3, I'll get plus 1. So x will be either the square root of 1, which is 1, or it's negative the square root of 1, which is also negative 1. On this side, if I add 4 to both sides, I add 4 to this side, the negative 4 will cancel. I'll add 4 to the right hand side, and I'll get 6. So x is either the square root of 6, or x is negative square root of 6. So we've got 4 potential solutions, and then I'd have to plug them back into my equation to make sure that they work. In this case, each one will work. So we've got 1 and negative 1, 6 and negative 6 as 4 solutions to this equation. The very last thing to do in this chapter is to look at absolute values. And I apologize, my absolute value signs kind of look like 1s, so I'll make them a little bit longer. So when we have the absolute value of something, of an expression, is equal to c, there are 2 possible ways for this to be true. U could either be equal to c, or u could be equal to negative c. Remember that when we take the absolute value of something, we just make it positive. So if u is equal to negative c, and I take the absolute values, this equation is still satisfied. So when you have the absolute value of something is equal to a number, there are 2 cases, and you just solve both cases. So again, we can simplify this guy. We've got 2x minus 1, the absolute value of 2x minus 1 is equal to 5. So 2x minus 1 is either equal to 5 or it's equal to negative 5. So we can write those down. 2x minus 1 is either equal to 5 or 2x minus 1 is equal to negative 5. Again, I want to solve for x, so I'll add 1 to both sides of this equation. When I add 1 to this side, I have to add 1 to this side. So I'll have 5 plus 1 is 6. And then I can divide both sides by 2 to get x is equal to 3. And then on this side, if I add 1 to both sides, again to cancel out that plus 1, the 2x will stick around, and negative 5 plus 1 will be negative 4. Again, I'll divide both sides by 2 to get x equal to negative 2. Here, I'm just going to plug these back in to make sure everything works. So let's look at the absolute value of 2 times 3 minus 1. So 2 times 3 is 6. So the absolute value of 6 minus 1, that's the absolute value of 5, which is 5. Oh, that one works. Let's plug in a negative 2 to see if this works. This will be 2 times negative 2 minus 1. Again, 2 times negative 2 is negative 4 minus 1. When we simplify this, this is negative 5. And we already said the absolute value of negative 5 is positive 5, so this also works. Both of these are true, and what you'll notice is that one gives the absolute value of 5, and the other gives the absolute value of negative 5. 5, hence 2 solutions. Let's look at one more of these. We have 4 times the absolute value of 1 minus 2x minus 20 is equal to 0. So again, our trick using the absolute value sign means that we'll need to solve for it explicitly. So what I'll do is I'll add 20 to both sides to get 4 times 1 minus 2. The absolute value of 1 minus 2x is equal to 20. Negative 20 and 20 cancel out. So I have this factor of 4 out front, so I'll just divide both sides by 4 to get the absolute value of 1 minus 2x is equal to 20 divided by 4, which is 5. Again, just like before, I'll take the absolute value of both of these are going to be equal to either 5 or negative 5. So 1 minus 2x is either equal to 5 or 1 minus 2x is equal to negative 5. We'll have one or the other. Again, I have this plus 1 on this side, so I'll subtract 1 from both sides to get negative 2x is equal to 5 minus 1, which is 4. And I'll divide both sides by negative 2 to get x is equal to negative 2. On the other side, if I subtract 1 from both sides, I'll have negative 2x is equal to negative 5 minus 1, which is negative 6. And I'll divide both sides by negative 2 to get negative 6 divided by negative 2 is 3. So we found both of our solutions. If we plug them in, they would both work. So we have our 2 solutions. One thing that I will quickly mention is that it could be the case that an absolute value does not have a solution. So for instance, if we look at the absolute value of x is equal to negative 3, this has no solution. And I don't even have to do any work. I know that there's no solution because the absolute value of a number is always going to be at least 0, if not positive. It can't be equal to a negative number. So here, the absolute value of x is equal to negative 3. Doesn't work. The absolute value of x has got to be positive. So it's sometimes easy to see that there's no solution whenever you get the absolute value of something is equal to a negative number. It could be a lot more complicated. The absolute value of x squared plus, let's say, x to the 1/3 power minus 6, if we set that equal to negative 27, I don't have to do any work. I don't have to do any simplification because the absolute value can't be equal to a negative number.